So next part of the question. Now we have two curves. The first pat represents the one we already know about, the first person who took a throw. That's the pat from A to B. That was the first person's throw. And then the next pat is the second person's throw from C to B. So this is the point B still over here. Now, the important trigger word here in this part is the word translation. And it's a translation from A to C. So that's a very specific maths thing, a translation from one point to another. So the whole idea is there's a translation from this point A to this point C. So every point has moved on by that amount, the same amount as A to C, to bring the curve fx, to transform the curve fx into the curve gx. So we've got to work out that translation before we do anything else, because that's the key to unlocking what gx actually is. So we need the point A to C. Now C is 0, 2. We've got to go back to the previous page to get A. A is minus 0.5, 2.565. Minus 0.5, 2.565. And if we look at that transformation, what has happened to the x value and the y value? Well, the x value has clearly gone from minus 0.5 to 0, so it has increased by 0.5. And the y value has gone from 2.565 to 2, so it's gone down by 0.565. And now the first thing we're asked is show that the center of the ball has reached its max height. So in the second pat, we're looking for the max height in the second pat. And so we can get every point by translating, according to, using the translation A to C. So it's no different for our max point. So let's just bring our max point in at this stage from the first graph. So in terms of g of x, or f of x, which was the first curve, the max point was, if we go back, we worked it out, it's the x value and the y value here. There's the x value, there's the y value. 2.177 and 4.529. And that's mapped onto the max of in the second curve. And we follow the same rule as the translation A to C. So the A value goes up by 0.5, so you have 2.177, that goes up by 0.5 to give us 2.677. And in a similar way, the 4.529, that goes down by minus it goes down by minus 0.565. That's 4, that's 693, 3.964. And that's the answer to part 3. That's why we were asked to prove that the maximum point of the curve gx is what we've just shown it to be here. Part 4, hence or otherwise find the equation of the parabola gx. Now before we go any further here, we just need to refresh our knowledge of parabolas and quadratic graphs and how they work. So very briefly over here as rough work, if you have a graph like, take a function like x squared, well, we should know that that's a curve with a minimum at 0, 0, centered on the origin. If you suddenly bring in, if you go x, if you just substitute x for x minus some number squared, for example b, to be squared, that minus b shifts the graph to the right b units, whatever b is. So now it's b across and not up. Another improvement on the graph, or another addition, is x minus b to be squared. If you put on a number here like plus c, for example, that rises the graph up c units. So this is all to do with the transformation section of functions on your course. So a minus b moves it to the right by b units. A plus c moves it up c units. So now the graph becomes b across and c up. If I put a minus in front of it, that flips the graph over. It's still, and now BC goes from a minimum to a maximum. And finally, it turns out that there's lots of curves. There are lots of curves that have BC as maximum. So there's the one we've just drawn, for example. But there are also others. I mean, you could have a curve here, for example, a quadratic curve that has BC as maximum, or you could have a wider one, maybe one out here. So all of those curves would be so far represented by minus x minus b to be squared plus c. So there's something missing. It turns out that there's a number missing in front here, and by setting that number, you're actually setting which of those curves you're using on the graph. So there's a number in front of the x minus b squared which tells you how narrow or wide the graph is. So we finally have an expression that covers all these quadratics, and there it is. You'll also notice that the b and c correspond to the maximum point. Now, keeping that in mind, we'll go back to our question. This is exactly what we've got. We've got a maximum point, and if you look at our example that we've just done, when you have a maximum point like BC, well, the b goes straight into the function there, and the c goes straight into the function there, and we're only missing a. A is then the only unknown. And it's the same here. We know that this function is going to be, and let's give it a name, it's g of x actually. G of x is equal to minus a, taking this expression down here, minus a times x minus b to be squared plus c. And of course we can sub the max value straight in. That's your b value, that's your c value. So g of x is equal to minus a into x minus 2.677 to be squared plus c, which is 3.964. And now it's just a matter of getting a. So we need one more equation to work out what a is. You can call this y. This is good because gx is the y value. So y is minus a x minus 2.677 squared plus 3.964. Now, do we know anything at all about this curve G? We know for certain one point that's on it is the point C, not 2. So again, when you know a point, you label it xy, that usually leads to the next step. So not 2 is on the curve. That tells you what to do next. You sub in 0 for x and 2 for y. So 2 is equal to tidy up that. 2 is equal to minus a into x, which is 0 minus 2.677 squared plus 3.964. 2 is equal to, or maybe we do it all in one go here, bring across the a into minus 2.677 squared equals, bring the 2 across as a minus to the other side, and you get 1.964. And when you work out a, what do you get? A is equal to 1.964 divided by, well, the minus squared is plus anyway, so you just get 2.677 squared. So let's work out that. That's 1.964 divided by 2.677 squared, and you get 0.274. And that's the missing link in our expression for g, for the function g. Once we have a, we fill it back in. So that goes back in there. And finally we have our answer. The function gx is equal to minus a, which is minus 0.274 times x minus 2.677 squared plus 3.964.